In front of you, we have a homework problem. This homework problem says use the formula f prime of x equals the limit as z approaches x of f of z minus f of x. That is all over the quantity z minus x to find the derivative of f of x equals 2x squared minus x plus 2. So unless I tell you on an exam, you can use the rules and techniques that we've learned to find the derivative. Because this tells me to do it a certain way, we're going to do it this way. Normally, if I asked you to find the derivative using the formal definition, I would have you using the limit as h approaches 0 of this f of x plus h minus f of x all over h. So this is another method that can be used using this definition to find the derivative. We just didn't look at this in this class, but let's show it using the way they want us to. And so we're going to look at the limit here as z is approaching x. Well, it wants us to find f of z. So I know I'm going into my function of f of x, and wherever I see an x, I'm rewriting it with a z. So doing that, I would have 2 times z squared minus z plus 2 minus, I need a parentheses here. I'm subtracting off the whole f of x function, which was 2x squared minus x plus 2 in our parentheses, all over z minus x. So let's just rewrite this by distributing our negative sign. So if I distribute my negative sign inside my parentheses, I'm left with 2z squared minus z plus 2, and then I'll have minus 2x squared plus x minus 2 all over z minus x. So I have some like terms in my numerator. I can combine my positive 2 and negative 2. Those cancel out with each other. And so now if I went in and I did direct substitution, I would have a problem because I would get 0 over 0. I would get that indeterminate form. So that told me I needed to go back and I needed to manipulate it. So the trick here is to rewrite your terms and then use factoring by grouping. So let's group our squared terms together. 2z squared minus 2x squared. And then the terms that aren't squared, minus z plus x, all over z minus x. So grouping the first two terms together, I can factor out a 2. And factoring out a 2, I'd be left with z squared minus x squared, which I notice right now is a difference of squares, which I'll go back and factor in a second. And then let's pull out a negative 1 from negative z plus x. So pulling out a negative 1, we would be left with z minus x all over the quantity z minus x. Okay, so again, we had a difference of squares in here, so we're going to rewrite that. So we're going to limit as z approaches x of 2, that difference of squares. So we can factor that as z minus x, z plus x. Then we have minus that quantity, z minus x, all over z minus x. So notice that in our numerator, we have common factors, z minus x in common. So we can pull out that z minus x from both of those groupings. And if we do that, we're left with this 2 here times the parentheses z plus x minus, we pulled out the z minus x from z minus x, so we're left with a negative 1 all over z minus x. So notice our factors of z minus x cancels with one another, and we're left with a limit as z is approaching x. I'm going to distribute my 2 inside the parentheses. So distributing that 2, I get 2z plus 2x minus 1. So now we're in the position where we can do our direct substitution. Wherever we see a z, we're going to plug in x. So there's only one z left in here. And so doing that, we get 2, I see a z, so replace it with x, plus 2x minus 1. So we have two like terms in here, 2x plus 2x, that gives us 4x minus 1. So we just found what the derivative of f of x was by using this rule. So let's just go back and check it really quickly. So looking at our function f of x equals 2x squared minus x plus 2, let's just think about it using our general power rule of derivatives. So if we bring down our power of 2, we get 2 times 2. So that gives me 4. Subtract 1 from my exponent, I would just get x. And the derivative of negative x is minus 1. And the derivative of that constant is 0. And so that derivative using the techniques that we just learned is 4x minus 1, which gave us the same thing as using that rule. So hopefully that was helpful.